Well, hey there, kiddos. Here is your Topic 3 Solving Inequalities video for your semester exam review. So number 1, here's a word problem. We're going to have to write the inequality, then solve it. So it's telling us 1/2 of the quantity, which means parentheses, of 5 less than 3/4 of a number is greater than 4 less than twice the number. So I'm going to have to write an inequality first. It's going to start with 1/2 of a quantity. Well, quantity means all of this goes in parentheses, and I have 5 less than, remember, is a flip-flop word with the subtraction sign, 3/4 of a number. So I have 3/4 of a number minus 5 is greater than 4 less than twice the number. So again, it's flip-flopped. So step 1, I'm going to have to multiply. Half of 3/4, just numerators times each other, denominators times each other. This becomes 3/8 x. Then I have to do half of 5. Well, half of 5 is either 5/2 or 2.5. I'm going to use the decimal because it works out to a nice, pretty decimal. It's not a big deal. Is greater than 2x minus 4. Well, now I have this fraction in my problem, and I'm going to deal with it in a minute, but the first thing I'm going to do is I'm going to move my negative 2.5 over here to the other side, because when I solve inequalities, I like to get my variables on the left so that when I read the inequality, I don't have to read it backwards. So I always like to put them on the left. So I'm going to add 2.5 to both sides. That's the first thing I'm going to do. And so now I have 3/8 x is greater than 2x. And if I do negative 4 plus 2.5, that gives me negative 1.5, so I have minus 1.5. Now, I'm going to clear my fraction. I don't want to have to deal with this fraction in my problem, so I'm going to multiply both sides by 8 so that I no longer have this fraction. So this becomes 3x is greater than 2x times 8 is 16x, and then 1.5 times 8, or negative 1.5 times 8, becomes negative 12. So this is going to stay minus 12. Well, I like to get my variables over here, so I'm going to subtract 16x. I'm running out of room. And when I subtract 16x, that's going to give me negative 13x is greater than negative 12. And then I'm going to divide both sides by negative 13 so that I can have x by itself. And remember, since I'm dividing by a negative, this is now going to flip my inequality symbol. So this is going to become x is less than 12/13, which is almost 1 whole, because 13/13 would be a whole. So if this was 1, 12/13 would be right before it. And so to graph it, I would put an open circle at 12/13, and that doesn't look like an open circle. It colored in on me. Try that again. So I would put an open circle where 12/13 would be, and since it is less than, I would draw my arrow pointing to the left, and that would be all the values that were less than 12/13. That problem was a booger. All right, number 2. 4 times the number is at least the sum of 2 times the same number and 6. Well, 4 times the number is easy, 4x. At least does not mean less than like you would think. If it's at least something, that means that it is that number or more, because that's the smallest value I can have. So this becomes greater than or equal to the sum of 2 times the same number and 6. So 2 times the same number, which would be x, plus 6 because it's a sum. So we get all my variables over here on the left by subtracting 2x from both sides. And so now I have 2x is greater than or equal to 6, and then when I divide both sides by 2, I have that x is greater than or equal to 3. And so when I graph that, 1, 2, 3, I have a closed circle at 3, and my arrow goes to the right because it is greater than. So number 3, 10 less than 5 times the number is less than 6 times the number decreased by 8. Now there's the words less than in this problem twice. The first one, and this is kind of an inky problem, because the first one you have to know that it means that it's 10 less than something, so this is subtraction. This one, when it says is less than, because it puts the word is in front of it, this becomes the symbol less than. This doesn't have an is in front of it. So remember, less than, flip-floppy when it comes to the subtraction sign. So you have 5 times the number minus 10 is less than 6 times the number decreased by 8. So all my variables are going to come over here to the left, so I'm going to subtract 6x. So that gives me negative 1x minus 10 is less than negative 8. And so now I'm going to add 10. So I have negative x is less than 2. Now there's a negative 1 here, so to get rid of it, I'm going to divide by negative 1. And because I'm dividing by a negative, remember my sign flips, so this becomes x is greater than negative 2. So at negative 2, I have an open circle. My arrow goes to the right because it's greater than. So now number 4 here is just, here's the inequality, we're going to solve it. But before we can do anything, I've got lots of simplifying to do. First things first, we've got to get rid of these parentheses. And if you'll notice, the only thing in front of it is this minus sign. So it's like having a negative 1 right here. So the 6m we haven't done anything with yet. Bring it down. But now I'm going to do negative 1 times 2m, which makes minus 2m. And then I'm going to do negative 1 times 3, which becomes minus 3. And this becomes 13 plus 4m. Well, 6 minus 2m I can combine. 6 minus 2 is 4m. Minus 3. This side I didn't do anything with. And so now I'm going to go cancel some stuff out. So I want variables on the left, so I'm going to subtract 4m and subtract 4m. And when I do, all of my variables cancel, and I'm left with the statement negative 3 is greater than or equal to 13, which is not a true statement. Negative 3 is not greater than or equal to 13, so this inequality has no solution. I'm not going to be able to graph anything. There is not going to be a value I can plug in for m here that will ever make this work. So that's what that means. Number 5 here, I've got to get x by itself. And so I've got to get rid of this thing that looks like a fraction, this dividing by 5. So I'm going to multiply both sides by 5 first off. So this 5 will cancel that 5. So I have 2x. Negative 2x minus 7 is greater than or equal to 45 because I multiplied by 5. I don't have x's to combine, so I can leave this over here on the left. I'm going to add 7 to both sides. So I have negative 2x is greater than or equal to 52. Then I'm going to divide both sides by negative 2. And when dividing by a negative, you have to flip your inequality symbol. And so this becomes negative 26. So when I put it on my graph, negative 26 we're going to put as way down here. Because it's underlined, I get to do the colored circle, and less than, my arrow points to the left. So now number 6, again, a lot of simplifying has to happen first. So we're going to do some distributive property. Negative 3 times 4 makes negative 12. Negative 3 times negative m will make a positive 3m because the two negatives will make a positive. Then over here, 2 times 4m makes 8m, and 2 times negative 14 makes negative 28. So like with all the others, I'm going to get all my m's on the left, so I'm going to subtract 8m from here and subtract 8m from here. So I have negative 12, and this becomes minus, because it's negative 5m, it's greater than or equal to negative 28. So now I want to get m alone, so I'm going to add 12. So I have negative 5m is greater than or equal to negative 16. And then I'm going to divide by negative 5. And so I'm going to flip my symbol to face the other direction, and this negative and this negative cancel each other out and just make 16/5. And if I divide that out, 16 divided by 5 is going to become 3.2. So we'll change that. It's a decent decimal I can deal with. So it becomes less than or equal to 3.2. So 1, 2, 3. 3.2 is a little past that, and I get to color in my circle. And less than, my arrow points to the left. So now let's talk about compound inequalities. Compound inequalities, you have stuff happening all over the place. So I have negative 5 is less than or equal to 2x plus 3 is less than 9. So my x is going to end up in the middle of my statement. So what I do, and I'm going to split this into 3 parts. I have a beginning, a middle, and an end. And whenever I do something, I'm going to have to, like, for example, the first thing I'm going to do is subtract 3. I have to do it from the middle, from the left, and from the right. So I have to do it from all three spaces, not just left side, right side. So now this becomes -8 is less than or equal to 2x is less than 6. Then I have to divide by 2 in the middle, on the left, and on the right. And it's a positive 2, so no signs have to flip. So this becomes -4 is less than or equal to x is less than 3. And so x is every number between -4 and +3. Now the -4 has the or equal to, so I get to color that circle in. The 3 though does not, so you leave it open, and then you're just going to connect it because it's every number in between, because the x is in between them. It's in the middle. So number 8 here, same kind of problem. It's a little simpler though. I have x plus 2 is what my inequality is going to be, and so to get x by itself I have to subtract 2 in the middle, on the left, on the right, and when I do that I get that 2 is less than or equal to x is less than or equal to 6. So I'll put this on here. Here's my 0, so here's 2 and 6. They both have the or equal to, so I get to color in both circles, and since x is in between them I just connect them in the middle. So number 9 here, Jimmy's car can travel between 380 and 410 miles inclusive. That means that 380 and 410 can be numbers in the problem. On a full tank of gas. He filled his tank and drove 45 miles. How many more miles can he drive without running out of gas? So what I know is that he has gone 45 miles plus X number of miles, because I need to know how many more there are going to be, has to be between these two numbers. Well, 410 is the bigger one, and he can't go over that, so it becomes less than or equal to. And compound inequalities, in order for it to be between, your symbols have to face the same direction. So the low one goes down here, and so my symbols face the same way. They get to have the or equal to because of this word. This means or equal. So you get to underline your symbol. So we'll solve it like the ones we did above. To get x by itself, I'm going to subtract 45 from every single side. And so I end up with 335 on the low end and 365 on the high end. So Jimmy can drive anywhere between 335 and 365 miles and still not run out of gas. Number 10, Javante's allowance is doubled and is now greater than $10, but not more than $16. What amounts could his allowance have been before the increase? Well, we know that his allowance was some number we don't know, and it got doubled, so that's times 2. It is now greater than $10, but not more than $16. So that the big number always gets put on the left. So if it's not more than 16, that means it's less than 16. And if it's greater than 10, remember my symbols have to face the same direction. Since this one was less than, this faces the less than direction, but this part of the inequality is written backwards, so it really says this is greater than 10. It's just written backwards. So to solve it, I want to get x by itself, so I'm going to divide by 2 everywhere. So I end up with 5 is less than x is less than 8. So x, his allowance before the increase, is anything between $5 and $8. That's the answer to our inequality. So there is inequalities. You're going to practice this now and see how you do, and then hopefully you can be ready for your exam.